What's up, math scholars? Happy Tuesday. We all just got back from a 4-day weekend, so everybody is super awake and excited to learn. Not so much. They look really tired, but we'll try to wake them up with a good math joke. What do you get when you take a pumpkin and you measure out its circumference and then you divide that by the diameter? What do you guys get? Pumpkin pie! Oh my gosh! How many of you guys carved pumpkins this weekend? I had somebody in my last class. How many of you guys picked pumpkins this weekend? Went to a pumpkin farm? How many of you guys picked apples this weekend at an orchard? Okay, clearly we need to get outside and enjoy fall activities a little more. All right, well, good news. It's 2.3 today. That kind of wraps things up. We're going to have a quiz over 2.1 to 2.3 on Friday. So tomorrow we'll start our review. Who's excited to learn math today? Woo! All right, today is adding, subtracting, and multiplying polynomials. 3 things we've already done. The problems just get a little bit larger today. The exponents, they get a little bit bigger today as well. So let's start with number 1. I always like to shout out, is this a foiling problem, class? No, why is this not a foiling problem? Nathan? No. Right, it's that big plus sign in the center, right here. You want to look at that guy? That's a plus sign. That means we're adding. Technically, those parentheses are not mathematically necessary. If I had written this problem out with no parentheses whatsoever, it'd be the same exact math problem. You would still just add. Okay? So I like using colors. If you want to look up all the colors, today's a good day for you. All the different colors of pens or highlighters. I'm going to go ahead and underline in blue all my x to the thirds. So there's one here, right up front. And there's one right here. And then I can go ahead and add those up. 2x to the third with 1 more x to the third would be 3x to the third. I'll get a new color. How about green? Negative 5x squared with 6x squared. Those guys can add up to a 1x squared. You can make the 1 invisible if you want. Let's get 3x. Uh-oh, doesn't look like he has any friends from the other group, so it's going to stay at 3x. And then let's get our negative 9, we use black, with our 11. Add those 2 up and get 2. All right, we're going to do board buddies for this one, so if you're watching at home, pause the video and try it by yourself. All right, we are back. Every single board buddy came up and got the same exact solution, so go ahead and check that you match. 3y squared was, or sorry, 3y cubed was the only y cubed term. That wrote terribly. Let me try that again. And then we've got a new color. There are 2y squared terms, so those add up to negative 6y. There was 2y terms adding up to negative 5y. And then there's only one term that had no variable. It's called the constant term, negative 5. Look pretty good. Okay, we're going to try this one together. It's a subtraction problem. Those ones get a little tricky. But we've done subtraction problems this year, so hopefully you remember what the strategy is. What's the strategy with subtraction problems? Yeah. Very good. Okay, so that negative distributes through to the second set of parentheses, he said. Everybody in the first set of parentheses stays the same. So 8x cubed stays the same, negative x squared stays the same, negative 5x stays the same, the 1 stays the same. This is where things start getting different. That negative will make it a negative 3x cubed. That negative will make it a negative 2x squared. That negative will make that a positive x. And that negative will make that a negative 7. Whew, there's like so many terms. It's so easy to lose a puppy along the way. Don't lose a term. Don't lose a negative sign. Be very careful. All right, let's start with our colors. I'm going to go with the blue here and the blue here. I think that would be 5x cubed. I'll do my green right here and my green right here for a negative 3x squared. I'll do my pink with my pink. I believe that's a negative 4x. And let me know if I'm messing something up. and a 1 and a negative 7 is negative 6. So does that look like what you guys got? You all agree? All right. All right, we're going to do one more subtraction problem. I've got some board buddies up here, and you can try this at home. Watching the video, though. All right, this one, we're going to keep this first group the same. We're going to take the negative and distribute to the second group, making it a negative d cubed, a positive 13d squared, and a positive 4. Probably where all these positives came from in our answers. All right, we need to do a hunt. Our d cubed are located here and here, and those would add up to 8d cubed. Our d squareds are located, just right here, I suppose, so 13d squared. Our d's are located here only, I believe, that's an 8d. And then our numbers are located here and here. And that would just be the number. So I think that is the correct answer. That's what all my little board buddies got here today. Any questions on that? Yeah. We do want our final, that's a great question. You probably couldn't hear that in the video. She asked, does it matter what order we put our final answer in? They normally do want that answer in standard form. So you want your highest degree first, and then you want to work your way down to lowest degree. So degree 3, degree 2, degree 1, degree 0. Okay. I probably wouldn't mark it wrong, but I'd make a little note to get used to putting that answer in standard form. All right, we've arrived at a multiply problem. It's a foiling problem. Now, it's a little bit more intense than just your standard foil. There's going to be more rainbows involved. As always, you have a choice of what method you want to use. Do you want to use rainbows, or do you want to draw boxes? I'm going to have my recommendation for you in a second. Let's pretend you're a rainbow person. You would draw your rainbow from here to here, from here to here. Every rainbow you draw is a multiply problem you would perform. You draw your rainbow from here to here, from here to here, and then finally from here to here, and from here to here. So if you lost track, that's 6 rainbows you need to draw. It's just multiplication matchups. So my recommendation, feel free to do the rainbows, but my recommendation would be to draw a box. It'll keep everything organized a little better. It'll organize all the 6 matchups you need to do. You'll need to draw a 3x2 box. It doesn't matter if it's 3 on the top or 3 on the side. You need a 3x2 box because one side's going to be labeled with your trinomial, your negative 2y squared, your 3y, and your negative 6. And the other side will be labeled with your binomial, your y and your negative 2. Personally, I draw a box anytime I'm multiplying groups larger than just a binomial times a binomial. So since we have that trinomial with the binomial, I'm going with the box. So it's my official recommendation. I'm not forcing you to use this method. All right, let's try it. Y times negative 2y squared would be negative 2y cubed. Y times 3y would be 3y squared. And then y times negative 6 would be negative 6y. Okay, bottom row. Beware of the double negative. Negative 2 and negative 2 is going to make that positive 4y squared. Negative 2 and 3y is negative 6y. And then negative 2 and negative 6 is a positive 12. Beware of the double negative. Now here is really where the box method shows its strength. Finding those like terms that you need to add up is as easy as looking diagonally. For the most part, they normally live diagonally. And those boxes I just drew the lines to will add together. So my final answer, I'll have a negative 2y cubed. These 2 boxes will add up to a 7y squared. These 2 boxes will add up to a negative 12y. And then I'll positive at the end. All right, I'm going to call up some more board buddies, so if you're at home, go ahead and try this by yourself. You can pause the video. All right, hello people at home. We'll do this super quick for you because all my board buddies are already gone from the board. They did great. The x and 3 can go here. 3x squared, negative 2x, and 4. Again, you could totally have this rotated sideways and it would still work. I did have a board buddy come up here on my left, if you want to look here in class. They put their 3 along the side and their 2 along the top. It still works fine. It still gives you all 6 of those matchups. So we got 3x cubed, negative 2x squared, 4x, 9x squared, negative 6x, and 12. And there, again, is your diagonals. There's where your like terms are at. So add up your diagonals. You'll have 3x squared plus 3x cubed, 7x squared, negative 2x, and 12. Okay, look good. All right, this is our first time we've ever seen something like this. A binomial times a binomial times a binomial. Anybody think they know what we're going to do? Any ideas? FOIL all of them, all at one time? No, just 2 at a time. Right, we're only going to do 2 at a time. And it's your choice what 2 you want to start with. I normally just start with from left to right. So I'll do those 2 first. Get that answer. It'll be a trinomial. And then take that trinomial with that binomial. All right, do you think that's enough information for you guys to do it with your board buddy? Do those 2 first. Get your answer. It'll be a trinomial. Then draw your boxes. So I probably would just do my rainbows here. I'll go ahead and do it. X squared, 1x, negative 5x, negative 5. Don't forget to add up your 2 middles. It would be a negative 4x in your middle. But now I'm going to go ahead and have you guys take it from here and finish it off doing our trinomial with our binomial, and that's where you can draw your box if you like that method. All right, hello people in the video. I have one set of board buddies back there still bickering over what method they're going to use. But we'll let them finish while I fill out my box. X cubed, negative 4x squared, negative 5x, 3x squared, negative 12x, and negative 15. Now, it's not always true that your diagonals are your like terms, but most of the time it is true. So x cubed, negative 1x squared, negative 17x, and negative 15, I believe. It's what all my board buddies up here got. And yay, they did finish it up in the back and they got it right. So they ended up not, here's what they were bickering over, if you're wondering. One you wanted to use box, one you wanted to use rainbows. So they were, the one erased the guy's box and they got mad, but they worked out in the end. They did the rainbows. They got the right answer, so we're proud of them. All right, I think that's probably good. I think you guys understand this enough. I can just give you the homework assignment to work on. Thanks for watching the video at home. Hopefully you have a happy Tuesday.